Hello everyone, welcome to the next tutorial. In this, I would like to talk about the situation and how to deal with the messy data. It's going to be a short video just to recapture things we have also discussed previously. So let's take example of if we add the true plus 5, what is going to be? If you suggested, if you thought it's 6, I think you are correct because true is associated with the equals to 1 and false equals to 0. Let's make a combined pose 2 and see what's the v1 variable is going to be. So again, 2 plus 5 is going to 6. And what do you think the class is going to be? Whether it's going to be logical, numeric, character. So it's going to be numeric. So this is how we do change the data type of in R. And let's try to do this. So here I'm just adding the true, which is in the character form, plus 1, and let's see. So it gave an error. Why? Its error shows the non-numeric argument to binary operator. So we are trying to add the non-numeric, which is in this case the character with the 1, and we can't, the R can't interpret the true as the numeric. So in the R, the hierarchy of the data types goes like this. So logical is the bottom, then it comes the integer, then comes the numeric, and the up topmost is the character type. So there are other functions are available to convert your data. Like if I want to convert this like false, right, to the logical, it convert into false. As you can see, there are no quotation mark here, right? And we want to convert to the numeric, yes, because true is associated with the 1. We can convert this decimal point also into the numeric, right? As character, can we do that? Yes, we can. And can we convert the logical true into character? Yes, we can. What about this? Can we convert true into numeric? No, as we have seen the earlier, true cannot be converted into numeric. Here T2 DW cannot also be converted. Similar goes 1 plus 1, it cannot interpret into the numeric. So that's why we are getting the error. Let's work with the list. So list again is a combination of different types of data, right? What I'm doing, I'm creating the number concatenation here, one data frame and one text, and putting those into the list function and calling it my list, right? Let me see what it looks like. So in the my list, I have my number, my data, my text. So how do I access this? So I want to see the my data. So you just put a dollar sign. Again, we have already seen this, and we can access the my data element, right? And we can also use the number, right? 3. So 1, 2, 3. 3 comes the my text. So it is showing my text here. And we can also subscript with the go to the 2 and highlight give me the 2. So that's why it's giving me 4 to 6. Splitting vectors in list. So we can, there is a two ways to do that. One, the let's say the air quality, again it's our inbuilt data type is a temperature, and we also only want to see the month, which is equal to 5, right? And that's what you can see. But there is a better way, so we can use the split function. So what it's going to do, it's going to split the temperature with the month, right? Let's do that. And it's a temperature for different months. Let's give a name to those. So I just created a one concatenated list with May, June, July, August, September, right? And let's put that names into, and now we can see instead of the numeric, it's changed the May, June, July, August, and September. We can also collapse list into vector. So unlist this temp. So that's what you get. So for each element, it is associated with the name. So with the numbers, we can how to do round off. So let's create a variable a, and if you want to round off this with two decimals, we can use the round function. There is again signif is also one function which do the same thing, right? Ceiling again, what's the top of this net value? So if it is 2.55, it's converted to 3, and floor it goes to the lower level. So in this case, 2.55 is 2. We can trunk remove the decimals using the trunk function. Let's see the sum and the mean in the data frame. So I have created this data frame here with a books row, right? And let's see what the data frame looks like. So it says purchase one, two, three, three columns and nine different rows. So I want to sum the column, right? Purchase one, two, three. So there's a function called call sum. So it's do the summation of this part, and this part. If you want to do the row wise, we can use the row sums, right? We can also use the column mean to get the mean of the column, and again to row mean to get the mean of the rows. Let's see how to summarize the series and let's load the library FVB2 and we'll use the A10 dataset. So this represents the sales of the 1992, right? And let's see the sum of community sum, right? From this. That's how, so what it's doing, it's just adding this. So this plus this plus this. So adding the next value and let's see the maximum of this, right? So 5.088335 is the maximum and the minimum is the 5 point, no, minimum, yeah, minimum is 2.81444. We can also plot total sum and include each month. So what I'm doing here, let me plot this. So it is just cumulative sum, right, from 0 to 12, and the axis represent the month and y represent the total sales, and the b type is uh, just the figure which you are using here. There are also just want to touch base on the scientific notation. So if you want to convert this into the E base, right? So you can do that, right? 7 E plus 06. Okay, let's see the dividing part and yeah, so this was very interesting one. 1 divided by 3 represents 0.33, right? What if I check this 1.5 minus 0 point that should equals to 1.3, right? True. What about this one? Very interesting. It's the same thing, right? 1.2 0 point t minus, so it should come 0 0.9, it should equate. But there is a reason why it is not equal, and let me show you what I mean by that. So sprintf represent the data, right? So this is what 0 0.9, and as you can see, it goes to different length, right? 30 in this case, and let's represent this. So you see, both these two are different, right? And let me run this one so we can do the comparison. This is equal. That's why the first one became success, right? And this one got failed because it was near equality. So to just to check, there is a function called all dot equal just to check the near equality. It will not check the very precise decimals. And if you want to make sure you are not looking for precision calculation comparison, you can use the all dot equal part. You can also set all dot equal 1.2. If the difference, it shows the difference is 1, and it's just to check whether it all dot 1 equals to 2. I would be no, that's false. If you want to read about all dot equal, you can always go ahead and check test if two objects are nearly equal, not the equal. So it says nearly equal. Let's move to the working with the factor. So I have created a one variable with the smoke type, right? And you have the certain observations here. I never, never, heavy, never, occasionally, never, never, regularly, regularly, no. So let's make it a table of it, right? We can see the heavy is 1, never is 5, no is 1, okay, occasionally 1, regularly 2. So we can create a factors for this. And what I mean by that, let me move it, create a copy of it, smoke 2, right? And let's see the level of the smoke too. So we can see there are heavy, never, no, occasionally, and regularly. And to change into the factor, we use the factor function here. So let me do that. and the level which I am creating is the never, occasionally, regularly, heavy. So divide everything, whatever data we have in this manner, and order it, right? And let's see how it looks like. So as you can see, it has divided everything into never, never, heavy, never, occasionally, and there is NA, which because no was not part of the levels, right? And let's see the levels. So these were the levels. Let's make it table after it. And to check the NA, there is again we can use which function to find out and is NA to check whether there is a NA. And in this case, the no was the NA part. And let's change the let's add NA option there in the smoke 2. And now the smoke 2 also has the NA part, right? And we can change the name of that to the invalid answer. Also, if you want to combine into yes, no, so we can find out, okay, from 2 to 4, make it yes. And if you see the labels, it will have the never, yes, and invalid also. Cool. So let's talk about the string part very briefly. So this string represent which are in the quotes, right? Text 1, you can see this is the string, text 2, this is a string, text 3 is the string. And the one thing which you notice here is the this dot na, right? So if it is not representing, it should come in the next line. So to do that, you can use the cat function. Now it is coming, so it is going to the next line and plus tab. So that's why it is the representation is happening. To concatenate, again we can use the cat function. So first thing, we are just combining the first and second, very simple process, right? If you want to separate it by next line, you can do that. Upper and lower case, right? Very basic part. Working with the dates. So date format is again very much used in multiple analyses. So if you want to convert as date, we can do that. And this, if you want a specific format you want to use, you can use it like this. To find which is your local language, so you can use the system.get_locale. So mine is English India, right? UTF-8. And if you want to extract the very specific, right? Let's create a date function, date variable, and if I want to only extract the days, right, from this, so just 0, 21, 22, extract the time, right, month, extract the year, right, and we can also